Hello everyone. In this video I'm going to explain about the load store instructions. We know about the load store instructions. The load instructions will going to store the contents of the register inside the memory locations, and the store instructions will going to store the whatever the contents in the address that will be stored inside the registers. So we'll go one by one. So first, before going to the types of transfer we are going to make, we'll study about that general instructions that are in the load and store instruction. First I'm going to go with the load instruction. As you can see here, it will going to load a word size of a data into the register. That means whatever the as you can see in this column, whatever the address is pointing to, that content will going to be stored inside the destination register. Similarly, in a store instructions, whatever the register content, that will be moved to the address pointed by this pointed by the address. So the content will going to be stored inside this address. So similarly, this is of a word size. When we say LDR and STR, it means that I'm going to either store or retrieve the data from the address to the destination, or from the destination register to the address of the word size. That means 32-bit. When I say LDRB, that means only the byte size data will going to be stored or retrieved from the memory location. The same thing happens with the store also. So in LDRH, the half of the word, that means whatever the maximum size of the register, that half the size of that register will going to be, data will be moved from either to memory to the destination register, or from the destination register to the memory location. Similarly, we can also use like a byte wise. This is like when we are using in ARM7, I'm going to I know the size of the register is 32-bit. So when I say half word, that means 16-bit will going to be stored inside the register. So when I specify LDR-SB, that means signed byte. So if there is a sign extension bit, then that byte will be loaded to the destination register. Similarly, you are going to load that to a I'm sorry, in this LDR-SB, a byte sign will be loaded to the destination register, whereas you are going to load a sign 62-bit to the destination register. Now we'll going to now I'm going to explain about the different types of a transfer that can take place in a load store instruction. So when I say a single register transfer, only a single data can be able to transfer from either destination register to the memory location, or else from the memory location to the destination register. Whereas in a multiple register transfer, you can able to transfer like array of a register, what the contents of the array of register to the array of memory locations, or from the array of memory location to the destination registers. And then we'll have a third type, which is called as a swap instructions. We'll see about that. In swap instructions, we are going to exchange the data from the destination register with the contents of the address. So I'll start with a single register load instruction. So as I mentioned before, you can able to transfer only a single data. So single data, either that will be of a byte size, word size, or the 16-bit 32-bit word data, or whatever that, only a single data can be transferred between the register and the memory locations. So we're going to have different indexing method here. So what does that means? Pre-index with a write back, pre-index and post-index. See, what happens is, whenever we want to transfer the data, so I can able to use the base address from which the data has to be transferred, or else I can add the offset to the base address in order to move the content. So if I want to if assume that we have defined an array in which I'm going to have a series of data. So instead of incrementing the R0 each time in order to fetch the data, I'm going to use this pre-index write back and pre-index and post-index method, where I can able to transfer the data from the memory location to the register without incrementing the R0. Within the single instructions, you can able to transfer the data. Let's see how it will going to work. So when I say pre-index with the write back, I'm going to use this exclamatory mark at the end of the instruction, so that after the new address that has been calculated, assume that let's say as this instruction says. So it will going to add the base address with the offset address. Now R1 is acting as a pointer. It will going to have a address with which this 4 immediate value 4 will get added. Assume that it is like a 8000, so 8000 plus 4. Now the new address will be copied to the R1 after the storing the content that was earlierly pointed by the R1. So this is about the pre-index. Let's go with an example. Before going to the example, let me tell about pre-index and post-index also. See, as you can see here, the offset is same as the pre-index with write back. That means the operation in the pre-index is similar to that of a write back. The only thing is the address is not updated after the execution. That means whatever the newly calculated address, that will not going to be written back to the this base address. And in the post index, it will only update the base register after the address is used. So first I am going to transfer the data, that is whatever the base address is pointing to, then I am going to increment it, and then the newly calculated address will be replaced with the earlier base register, so base address. So let's take an example and then we can able to understand it properly. So assume that what the contents of R0 is 00, and then R1 is in context to this instruction, these examples are being explained. Now just assume that R0 is a destination register and R1 is a base register. Now the base register holds the address 9000 or 90,000 like that. So now in the memory location, so now R1 is acting as a pointer which holds the memory location 9000, 90,000. So now this address, so this should be 9000, I'm sorry, 09. So now it's fine. So now the address 9000 is pointing to a data, or the data hold by the address 9000 is this one, 010101, somewhat like that, and the memory location 9004. So assume that you are going to have an array of memory locations. In the first location you are going to storing this data, and in the second memory location, so when I say second memory location, that has been, it is incremented by 4 times, 4 bytes has been incremented. Why? Because it is of a 32-bit byte. As you know, each memory location can able to hold a byte size of a data. So either big endian or little endian method, you will need 4 memory locations in order to store this 4 byte of data. That's why I just mentioned it as a next memory location. So in the next memory locations, I'm going to have a data like a 02 or 0202 like that. So when I'm going to execute this instruction, let's say with a pre-index method, so what happens is, so as per the instructions, this is the base address and this is the offset address. Now a base address is nothing but this 9000. When I add this offset to this base address, it will start to point to the next location. As you can see here, see when I'm going to execute this instruction, the base address will be added with this one, and whatever the contents of this address, the newly calculated address, that will be stored inside the R0. See, as you can see here, the address of the base address is 900000, that will get added with a 9000, sorry, plus 4, that makes it to point to the data, this one. So this newly calculated address which is pointing to a data, that data will going to be stored inside the R0. So this is about the post operation. That means after the execution of this will be the contents of R0 and R1. See, as you can see here, now the R0 will going to have the data, this 0202, and after the execution, the newly calculated address which was like 9004, that will be written back to the base address. So this is what we do in a pre-index with a write back. So in just normal pre-indexing method, so we are going to do the operation similar to the pre-index with a write back. Only thing is, I'm not going to update that newly calculated address. As you can see here, it will also going to move the location, sorry, move the data 0202 like that, that will be moved to the R0, but whatever the newly calculated data, that will not going to be updated in the R1 register. So it will going to have the same value or the earlier value which it was having before execution. Now post indexing method. So in the post indexing method, what happens is you have to increment the address, or the newly calculated address should be restored in R1 after the movement of the first data. That means, so R1 is pointing to, now as per the precondition, that means before execution of the this instruction LDR or not, like this one, whatever the content of R0 is like this one. So this is the destination register where you are going to store the data. So in R1 you are going to have a base address 9000. So as you can see here, whatever the data that is pointing by this address, that will be stored first to the destination register, and then the newly calculated address will be updated in the base address register. So the pointer will going to be updated after the movement of the first data. So this is how the indexing method will going to work. So let's go. These are the some of the addressing mode. That means how you are going to specify the offset address within the instruction in order to move the data from the memory location to the register. So if we use either, we can use plus or minus. That means whatever when we use a plus means that means it will going to add, that means that it will going to move in the forward direction. So similarly, if I put a negative sign with the offset address, it will going to minus the sign. That means it will going to decrement the address, and then it will going to store the data that are the present in the address. So either you can able to move you can able to specify the offset address with the immediate value, or else you can just put that offset in a register, and then you can specify this register within an instruction, and then you can then there is another type which called as a scaled. So it means that address is calculated using the base register and the barrel shifter operation. So when I say I'm going to use the barrel shifter operation, you can able to use this LS, a rotation operation, or a rotation operation. So see, as you can see here, this is LSR 004. Like that, you can able to use that inside your instruction. So every instructions inside the LDR will going to have these kind of indexing, like a pre-index with a write back, pre-index and post-index. Remember, so pre-index will going to update the newly calculated address to the base address register. In pre-index register, you are not going to update the register, and in the post-index, whatever the data that is currently pointing by the base address, that will be stored first, and then the newly calculated address will be updated by to the base address register. So this is how I'm going to use the so this is all about the addressing modes of a load instruction itself. So this is when I'm trying to move a half word or signed off word or a signed bit, as I explained in this one. So you can able to yes, in this like this instructions, you can able to do that with the indexing method. Only thing is you have to put that LDRB, like LDRBH, like that you have to specify in this address mode, and the same thing will going to be, the syntax will going to be like same thing. Only thing is that instructions or opcode will going to change. So the same things happens with the store operation also. That means store operation means you are going to store the contents of this destination register to the address. So again, I'm going to we're going to use the pre-index with the write back method, pre-index and post-index also. So remember, again once again I'm going to tell you that, so whenever I'm going to have an base address with an offset address, both will going to be get added. So now in this case, assume that or else consider that R1 is just a pointer which is pointing to an address location. That address will going to get added with this 4, and that into that location the R0, whatever the contents of R0, that will be placed into that newly calculated address. And now after the placement of this data, the address R1 will going to be updated by the newly calculated one. So in this pre-index method, I'm not going to update the base address register. In the post-index method, so after the movement of the data from the destination register to the memory location, then I'm going to update this register. So we're going to have a different. So when I different conditions or different specifications. If I am going to put that both the offset and base address within the brackets, then I'll call that as a pre-index. So when I put the base address within a single bracket, or else I'm not going to, if I'm not going to put that offset inside the bracket, that means I'm going to do it on a post index method. So this is how I'm going to move load and store instructions with a single data transfer. As whatever the things that I have explained here, this is for only for a single data transfer. When I go for a multiple transfer means like you will going to have an array of a data that has to be moved into the register contents, or else if you want to move the contents of a register like a series of R1 from the register starting from R0 to R7, R10, whatever it is, the number of register is dependent on the program that you have written. So now if you want to content all the content of the register into the memory locations, you are going to use a multiple register transfer. That means you are transferring a multiple data within a single instruction. Now I'm going to use an LDM and STM which specifies that load multiple register. So you are going to specify the register within the braces and you are going to set the address here. See, we'll go for an example, then you will come to know about that. So along with this LDM instructions, we are going to use some addressing mode as we are using here with pre-index and all those things. Here also we are going to use some addressing mode. That means along with this opcode LDM, I'm going to use this addressing mode. So when I use LDM IA, so IA means increment after that tells the processor that after each transfer you have to increment. So after the transfer only you have to increment the registers or the address location. Similarly, increment before. So it means that before transferring of the data you have to increment the address, then you have to transfer the data. Similarly, that happens with the decrement also. Either you can able to increment before and after, same wise you can able to decrement it before and after the data transfer. Remember, it is not about the execution, before execution or not after execution, it is about the before transferring and after transferring. So we'll take an example for that and let's see how it will going to work. Consider this example. So this is about the precondition, that means before the execution of this instructions. So just zoom it so that it can able to clearly see it. And now assume that there is a memory location 80010 and I'm going to increment it. See, as I told you before, each data will going to, so this is nothing but 03 means there will be an 0 will be appended at the MSB bit, so that it can make up of 32-bit wide. So in order to store the 32-bit you need like 4 bytes of a memory location. That's why the memory location that has been specified here is incremented by 4 bytes. So the first location will be like 10, next 14 and 18. That means each time I'm going to add the 4 bytes in order to point to the next data. Now assume that these are the contents of memory location itself. Now assume that these are the register contents. Now R0 will going to have the first address. Now the R0 is nothing but a destination register or a pointer which is pointing to this data 01. So now I'm just clearing all the contents of register R1, R2 and R3, so that the newly whatever the data that is pointing by this address will be stored inside this R1, R2 and R3. So this is about LDMIA, that means load multiple data and increment after. So that means after transferring each data, that means each data the address will going to be auto incremented. So let's see what happens. So as I told you, this LDM is an opcode. Along with this I'm going to use an addressing mode in which the data has to be transferred. So it will going to select the addressing mode. So either I can able to use that increment after or decrement after, or like IB, like increment before, like that. And I'm going to specify, I'm going to explain that IB also here. So now let's get into this. So when this is the pointer from where you have to move the contents of address to the registers. So whatever the register that has to be stored, whatever the data that you want to store that into a register, that will be specified within the flower brackets, not as a normal normal bracket. So when I'm going to execute this instruction, see, as you can see here, R1 will going to have the first data 0 1, after that increment after I told. So in this instruction I have told that after each transfer take place, the address should be incremented. So as I mentioned here, the exclamatory mark, the R0 will going to be updated each time the transfer will going to take place. So at first R1 will going to have a 0 1 value, then after that the R0 will going to be incremented, and it starts pointing to the second location. That data will be stored inside the R2, and in R3 I'm going to store the third data. See, it will going to store the data only for 3 times. Why? Because I have mentioned only 3 registers here, as you can see here, R1, R2 and R3. So 3 data. So only it will going to take only 3 times, or the 3 data will going to be transferred and stored inside the 3 registers, and after that the instructions will going to come out, or the execution will going to come out of this instruction, and the next instruction which I have specified in the program code, that will going to be executed. So it will going to transfer the 332-bit size of a data into the register. See, in contrast to this, in contrast to IA, if I am going to use that same data or the same instruction, only thing is, if I'm going to change the instruction to IB, means what happens is, so I have told incremented before, so whatever the data that is pointing here, that will be incremented first, and then it will going to start storing here. So that's why here in this condition the first instruction will going to store the first data, right? So as I told you, this is increment after the first transfer take place, it will going to increment. So it will not be in the case like this IB. That means let me write this one. Yeah, here itself it has been mentioned here itself. So LDMIB, that means increment before. So the contents of the R0 will going to be incremented first, and then the transfer will going to take place, and then 3 bytes of the memory location, the contents of 3 bytes, 3 memory locations will be stored inside the corresponding register that you have mentioned inside the instruction. So this is how the this is how the load store instructions with the multiple transfer will going to happen. The same thing will going to happen with the store operation also. So in store operation, you are going to specify the memory ranges or the destination register from which the destination register from which you have to store the memory locations. You are going to specify the register within the braces, and then you are going to specify the address. So each time the data transfer take place, either the address will going to be incremented before or after the data transfer that take place. So this is about the load store instruction, and the third one is a swap instruction that I'm going to explain here. Let me explain this one. A swap instruction. The swap instruction is nothing but it will going to exchange the contents of destination register with the address that you have specified within the instruction. So when I say, for the example, when I say R0 comma R1 into R2, so now whatever the contents that is specified in the R2, that will be replaced with the R0, and then R0 contents will be swapped with the R1. Similarly, you can able to exchange the data of byte size only. Then when you say byte wise, only the lower 7 bits or lower 8 bits will going to be swapped. So these are the swap instructions. It is a easy one. Only thing is it will going to make the exchanges. So first R1 contents will going to be placed in the R0, and then R0 contents will go to the R2 register, or else the address specified in the R2 register will be stored with the value that contains of a R0. So this is about the load store instructions. Just go through some of the examples in the textbook, then you can able to understand it very much clearly. Only thing is you have to concentrate on that this indexing method, whether you are doing a pre-index method, post-index method, or pre-index with a write back. Remember once again, pre-index with a write back will going to update the base register, whereas pre-index will not going to, so not going to update the base address. And in a post-index after the data transfer take place, it will going to update the base register. So this is all about the LDR instruction. Thank you very much.